Today's lesson is a revising or a revision about how to label points, lines, and angles, plus types of triangles and the main types of quadrilaterals. Okay, we have such this diagram. How we can name these figures? What about this angle? What about this one? How about these two lines? What this piece is called? Okay? First thing, what is a point? A point is a name of a specific location in space, such as these 2 points. This is point C, this is point D, and when you name a point, you have to name it or label it by an uppercase letter. Okay, so any point in the space, okay, and such this one, I can label it as point A. It must be an uppercase letter. Okay, this is another point, point M. For example, this point M in the space, we give it an uppercase letter. You can name it whatever you want. Okay, types of lines. The first type is a line. A line in this picture consists of 2 points. It has no ending or starting place for the line, okay? But the 2 points are located on this line. See, it goes forever both sides. We can write it as line AB or line BA. You can switch the places when you name a line, and you put this small draw of a line above the name of the line. Okay, so you can name it AB with a small sketch of a line above it, or BA with a small line on above. This is how we write it, how we say it, or how we read it. We read it as line AB or line BA. You can switch the places while naming. Okay, the second type is line segment. What is a line segment? A line segment is a piece of a line that has a place to start and a point, not a place, a point to start and a place to end. So here is the line segment of AB, the line segment of DG. This is the line segment of DG, started from D, ended with G. Or let's say this is the line segment of BF. Okay, you can read it or write it as line segment AB. Give it this simple. It has no arrows on above it, on the top of it, and you can write it as line segment of BA with the small segment on above. Okay, so for these line segments, we can write it as AB with this small segment on above, or DJ, the same thing. How we read it, how we say it, we read it as line segment AB, or the other one is line segment DJ. Okay? About the third kind of lines, which is the ray. I'm gonna cover this one. A ray has a point to start with, and the other one goes infinitely or goes forever. We can write it as CD because it started from D, ended with started with C, goes to D. And how we read it as ray CD with this small symbol on the top, a symbol of a ray on the top of it. Okay, what's the common mistake? The common mistake that they write it starting from D to C. They write it as ray D C, which is wrong because the ray started from C to the direction of D. Okay, so don't mix it up. So when you want to talk about a ray, put the first letter where the ray starts. Next, angles. Angles, what are angles? Angles are two rays starting from the same point, okay? So, how do we read it? You can read it in both ways, starting from C, going to A, after that going in direction of R. So you can name it in both ways, C-A-R or R-A-C, okay? And you are going to put the symbol of angles in front of the name of the angle, okay? So we can write it angle C-A-R or angle R-A-C, okay? And that's how we read it. But what the common mistake is, some students, they mix it up and they name it such as A-R-C, A, then R, then going after that to C. You know, there is no line segment between A, R, and C. So always the vertex must be in the middle. In the middle. So this is totally wrong. Let's go to the previous slide. Look, the vertex is in the middle while naming an angle, okay? Next, perpendicular lines, and how we can write it in symbols and read it. So line CD and line AB are perpendicular. How we represent it using notations? Okay, this is how we write the name of the line AB. It is a line, so you have to put the symbol of a line on above. And this is the symbol of perpendicular lines. And here is the name of the other line, CD, line CD. How we do read it? AB is perpendicular to the line CD, or if you want to switch the places while naming, it's okay. So line BA and line DC, they are perpendicular to each other. How do we read it? Line AB is perpendicular to line CD in this case. The other case, we read it as line BA is perpendicular to line DC. Okay, parallel lines and how we write it in symbols or notation. Okay, so here is two parallel lines, line CD and line EF. How do you write it? We write it as line CD is parallel. See that? This is the symbol of parallel lines to line EF, or if you switch the places, it's okay for lines only, lines and segments, but not for rays. And the other way is line DC is parallel to line FE. Again, how would you say line C? How we say it? How we read it? Line CD is parallel to line EF, or the opposite way when you switch the name of each line. Line DC is parallel to line FE. Okay. Sometimes on the board when I write it as line CD, a little bit of taking up an angle. EF, line EF, it's okay if sometimes it's a little bit have some angle. Okay, now we are talking about triangles. How do we classify triangles? Remember, this class is to revise geometry that we took in previous classes in previous grades, grade 3, 4, and 5. Okay, how do you classify it? Yes, in two ways. The first way, according to the lengths of the sides. The second way is naming them according, or classify them according to types of angles for each triangle. So the first triangle here, okay, how to classify a triangle? In this case, we are classifying according angles, okay. Take a look. Acute angle, and an obtuse angle. So we gave it symbol that triangle. See, we can symbolize. We can give the triangle symbol by drawing a small triangle, saying that triangle CAR, because if we wrote it as like CAR, you are talking about the angle CAR. So you have to put the symbol of a triangle. The triangle CAR is an obtuse triangle. Why? Because it has an what? An obtuse angle. So the first one is according or classifying triangles according to the angles. This is an obtuse angle. Second thing or second type, all the angles are equal. So in this triangle ABT, they wrote it as BAT. Sorry, BAT. You can name it in the order that you want. So triangle BAT is an acute triangle. Why? Because all the three angles are acute. Okay, the third thing, when a triangle has a right angle, in this case, triangle PAT, the triangle PAT is a right triangle. Why? Because it has a right angle at vertex P. Now, the second way of classifying triangles is by looking at the lengths for each side, okay? So, in this triangle, I can see it has 3 different lengths. So, any triangle that has 3 different lengths is called a scalene triangle. It has no congruent. Congruent, that means equal, okay? So, a scalene triangle has no congruent sides, or scalene triangle has no equal sides. So this is a scalene, 3 different angles. And yes, if you have this in your mind, a right triangle can be a scalene triangle, because let's say this is 4, this is 6, and here is 10. Yes, so this is a scalene and a right angled triangle. Okay. So I can name it 2 different ways. Okay, the second type is called the isosceles. Isosceles triangle, when you have 2 equal sides and the third is not. If you have in mind another question, can an isosceles triangle be an obtuse triangle? Yes, such as this one. For example, let's say this is 15, here's 9, here's 9, 2 equal sides, and it has an obtuse angle. Yes, an isosceles triangle can be an acute triangle such as this one, and can be an obtuse triangle. The last one, when all the 3 sides are equal, is called an equilateral triangle, because all the 3 sides are equal. And always any equilateral triangle, all the 3 angles, they have an angle that has 16 degrees. All the equilateral triangles. The third part of our lesson is talking about quadrilaterals. Sorry guys. Okay, quadrilaterals, you can classify them into 2 main parts. Okay, the first part, what is quadrilaterals? The quadrilaterals, any polygon that has 4 sides. Any quadrilateral or any polygon that has 4 sides is called a quadrilateral. There's main 2 kinds. When there's 2 sets of parallel sides, that means when this side is parallel, these opposite sides are parallel, those opposite sides of parallel, so it has 2 sets of parallel sides, same as for the parallelogram. Parallel, opposite sides parallel, opposite sides are parallel. Same for the rhombus and the square. The difference between them is the length of the sides and the size of the angles. The second set is when they have one parallel opposite side. The opposite sides are parallel or less, such as the trapezoid. It can be called the trapezium. Both of them are the same shape. So in the trapezoid, it has only one pair of parallel sides. The other two sides are different. Okay, and there is non-specific quadrilateral. It has no specific qualities, such as this one. Another kind I must to mention about, which is the kite. The kite, those sides are equal and those sides are equal. In this case, most of the kites, they have no parallel sides, okay? But the main character for the kites, then when you draw the diagonal lines between the opposite angles, those diagonal lines, they do form a 90 degree, or they are going to be perpendicular to each other. So kites, they do go or refer to this group. It has maybe it will have one set or two sets of parallel sides, but in general it has no in general cases it can't be it can have two parallel sides, two sets of parallel sides. It can has whether it's gonna have two sets of parallel sides or none. So that's why I didn't mention it in the beginning. So let's go. So quadrilaterals with two sets of parallel sides. Let's take specifically about parallelogram, rectangle, square, and the rhombus. The main characters for the parallelogram: two sets of parallel sides. This is first set. Second set, two pairs of congruent sides. Again, the word of congruent, that means equal sides. So this opposite sides are equal in length, those sides are equal in length, and they are parallel. The square, the same characters of the parallelogram, but the main character of it, that it has 4 right angles. Okay, 4 right angles. So two sets of parallel sides, two pairs of congruent sides. Congruent, that means equal. Two pairs of equal sides and 4 right angles. About the square, which is the only regular quadrilateral. That means it has 4 equal sides, 4 equal angles. That's why the square is the only regular quadrilateral, not the rhombus, not parallelogram, not the square, because the rectangle, because the rectangle for not the 4 sides are equal, same as the parallelogram, but in the rhombus's case, the angles are not gonna be all the same, only the opposite angles are equal. Okay, the same as in parallelograms, opposite angles are equal. Let's say this one is 60 and this one is 60. This one is going to be 120 because we took it in interior angles. Remember, transversal angles. So 120 here with 60, they add up to 180 because this is transversal line crossing two parallel lines. Okay, so opposite angles are equal for parallelogram. The same as for rhombus, opposite sides as opposite angles are equal, but the 4 sides are equal. That's why that's the difference between the parallelogram and the rhombus. It has 4 equal sides and the characters for parallelogram. The second set that has a quadrilateral with 1 or less sets of parallel sides. For the trapezium or the trapezoid, the trapezoid has only, the main character of the trapezoid, it has only 1 pair of parallel lines. But there is a special case, it's called isosceles trapezoid. Isosceles trapezoid, when the pair of the other sides, they are equal in length, such as here is 4, here is 6, here is 3, 3. When the other sides of the trapezoid, they have the same base angles and the upper angles are equal sides, okay, it's called an isosceles trapezoid, okay? And this is the non-specific quadrilateral. There is another one. I don't know if it has a specific name, but it has for different angles, for different sides maybe, okay? So this is a non-specific quadrilateral. Thank you for listening. I hope you will enjoy the exercises.